Now that we've defined a mole, we can calculate the mass of 1 mole of an atom or 1 mole of a substance, right? Which would be its molar mass. So I want to remind you about atomic mass. This is the average mass of a single atom in atomic mass units, which is AMU. And then we have molar mass, and this is the mass in grams equal to the mass of an individual atom or molecule in AMU. So what that means is if you go and look at the periodic table and the number underneath the element symbol, which is a decimal, is the molar mass. So for example, if you have 1 atom of helium, right? So find your periodic table, look at 1 atom of helium, and what you're going to see there is a number, and depending on the periodic table, it might be a little different, but 4.003 or 4.000. Now, the atomic mass of that is 4.003 AMU, but molar mass, which is related to the moles, is the same value as that. And so what that lets us know is that 1 mole of helium, which is 6.022 times 10 to the 23 atoms, is 4.003 grams, okay? And so from this, what we can figure out is 1 mole of helium, sorry, I got ahead of myself there. And so from this, what we can figure out is the molar mass, which is sometimes related, is called an M, like that, kind of like a cursive M of helium, is 4.003 grams per mole. Now, older texts are going to have molar mass and molecular weight used interchangeably, and because I am also older, I will use those interchangeably. So I wanted you to recognize that. And so we have that kind of cursive M there for molar mass that we use as well. All right, so let's talk about what we do when it's more than 1 atom. When it's more than 1 atom, we add all of the different atomic weights or together to give us a molecular weight. So what do I mean by that? If we look at sulfur trioxide, which is here, right? The molar mass of that is 80.06 grams per mole. And we get that by looking at the periodic table and saying, look, 1 sulfur, right, on the periodic table times the molecular weight, which is 32.059 AMU, equals 32.059 AMU. Ran off the page there. Let me readjust, right? AMU. And then we have 3 oxygen atoms, and we multiply that. That's 15.999 AMU. And that gives us 47.997 AMU. And we come here and we add these together, and that gives us 80.056 AMU. But we also know that 1 AMU and 1 gram per mole are mathematically the same. So we would say, look, this is also 80.056 grams per mole. what you're going to see here is, because some periodic tables only go to 2 decimal places, it is okay to round to 2 decimal places, but don't go any lower than that. So you always want to use 2 decimal places, and so it would be 80.06 grams per mole. Okay, and the periodic table that I gave you has 2 decimal places. So keep 2 decimal places. Don't go any smaller. You're more than welcome to go larger if you want, or more. Use more decimal places, but 2 is a really good area. When we talk about this, we've already introduced this and calculated on the previous slide. So molecular mass is the mass of one molecule of a molecular sorry, I said molecule here, mole of a molecular compound, right? When we look at this, we've already calculated that for sulfur trioxide. So the molar mass there, or the molecular mass, would be 80.06. When we talk about ionic, so this is generally used for molecular compounds, which are covalent. When we talk about formula mass, we use these for ionic compounds, but it's the exact same thing, really. It's because with formula mass, there's one formula unit of an ionic compound. So, for example, if you had NaCl and you were to add those together, we would get 58.43 grams per mole. This is linguistically, this is newer. So sometimes you'll still see these interchanged, like something ionic will be called the molecular mass, or so I just wanted you to be aware of it. But if you hear formula mass, it really means in practice the same thing as the molecular mass, right? You still add up these individual atomic weights and you get the molecular mass. So these are a lot of synonyms really for the same number that you're going to use in conversions. Okay, so let's do an example. We're going to calculate the formula mass and molar mass of water, which is H2O. So when we look at this, your book, again, these things are being used interchangeably through several different books. So when we talk about formula mass here, in your book, it's talking about the AMU that's numerically equal to the molar mass. So if we were to look at water, for example, this is how we calculate these. We would say, look, there's 2 hydrogen atoms times, we'd look at the periodic table and see 1.0078 AMU. All right, and that would give us 2.0156 AMU. And then we'd say, look, there's 1 oxygen atom times 15.999 AMU, and that gives us 15.999 AMU, right? And so we would get 18.015 AMU. And so when we look at this, right, when your book asks for the formula mass, it's asking for the AMU, but when we go and look at the molar mass, that's where we use grams per mole. And so because it's equivalent, it's 18.015 grams per mole. It's also okay, 18.02 grams per mole, depending on your periodic table. So lots of different terms for the same number numerically. Now, let's talk about how we can use this, because that's where it gets really interesting. we know that moles are counted numbers that relate to the number of atoms. And so when we do chemical reactions where we have our number of atoms, that becomes very unwieldy. And so instead we use moles. But our mass in the lab, our scales in the lab, our balances, can't weigh out moles, right? They weigh out grams. So we have to go from kind of this counted number to grams, something we can physically use in the laboratory. And so molar mass helps us with that because it tells us how many grams are in 1 mole. So what is the mass in grams of 3.01 moles of sulfur trioxide? So when we look at this, we've got to go from moles to the mass. And the conversion factor we're going to use here is the molar mass or molecular weight. Your book is going to use a single M. Sometimes you're going to see me fall into a habit where I use 2 M's. So just kind of be aware of that. So we start with our number of moles. We have that, and we're asked to figure out the mass. So we say, okay, I have 3.01 moles. Okay. And then you need to calculate the molar mass. Now we've already done this. This is sulfur trioxide, so we did this on the previous page. And I want to say moles of sulfur trioxide here. And so we say, great, we need to put the moles in the denominator, so it will cancel. And then when we do this math, we get 240.9685 grams. And so we need to look at our significant figures. When we look at our significant figures, there are 3 significant figures here. So that means our answer needs to have 3 significant figures here. So we're going to look at this 9 to see we need to round, and we need to round to 241 grams. And so that tells us if we want to react 3 moles in a chemical reaction, we need to weigh out in the laboratory 241 grams. Now, we can also convert from the number of grams to moles. So if we go to this example, it says how many moles of sulfur are in 1 kilogram of sulfur. So when we're looking here, we know that molar mass is given to us in grams per mole. Those are the units. So even though we're given kilograms here, to be able to go from any sort of mass to moles, we have to convert to grams first. So when we do this and we think about how we're going to set this problem up, we say, okay, hey, look, I want to get moles over here. And if I'm going from some sort of mass unit, I need to convert to grams so I can use the molar mass so that the grams can cancel. So then I need to take my kilograms to grams. So one of the ways to solve this problem is to think backwards. And so when we set this up, we say, great, we have 1 kilogram. And we know we have 1,000. 1 kilogram of sulfur, 1,000 grams of sulfur in 1 kilogram of sulfur. Now, you can stop here and calculate this and get 1,000 grams of sulfur if you want. But me, I'm lazy. To do that, you got to write things again, and I just want to work the whole problem. And so I'm going to go ahead, and so we've done this part of the problem. So I'm going to go ahead and focus on this part of the problem. And I'm going to come here and I'm going to say that's great. I'm going to look at the molar mass of sulfur, right? We find this using the periodic table. And we say, all right, there's 32.059 grams of sulfur in 1 mole of sulfur. Now, before I pick up my calculator, right, I want to make sure my units cancel because that's a double check. That's going to be your first clue that you haven't put things in the right place. And so I have a kilogram in my numerator. It cancels with a kilogram in my denominator. I have, let's use purple. I have a gram of sulfur in my numerator. I have grams of sulfur in my denominator. So we can see that those cancel. So now we're left with moles of sulfur, which is what this problem is asking for. So now I'm going to pick up my calculator, and if it's in the numerator, I'm going to multiply. So 1 times 1,000, we multiply those, and that's in the denominator, I'm going to divide. So then I divide by 32.059. When I get this, I get 31.192 moles. Now, when we go back and we look at this, we can see here that there are 3 significant figures. So that means my answer here has to have 3 significant figures. So I'm going to look at that guy to round. And so when I do that, I get 31.2 moles as my final answer there. So these are different ways to convert from either grams to moles or moles to grams. And you might have to do an additional metric conversion with that. So you just need to be aware. So here is a summary of the things that we've learned in the last 2 screencasts. And this is what we looked at in this screencast, where we can go from grams to moles, where we're either dividing by the molar mass or multiplying by the molar mass. But then from the previous screencast, we learned, look, we can also go from moles to particles. And so we can put these conversions together now and go from grams to particles as long as we convert to moles first, either way. And so I like to say in chemistry, all roads go through moles or lead to moles, right? And so we've got to get to moles and then go on. So let's do an example, okay? This says calculate the number of atoms of sulfur in 1 gram of sulfur. So we're asked for the number of atoms of sulfur. So I'm going to put this over here. Number of atoms of sulfur. That's what we've got to get to. And way over here, we're starting with 1 gram of sulfur. Okay. We cannot go directly from grams to atoms. We must go through moles. It's kind of like all roads lead to Rome, if you've ever heard that. It's like, all roads lead to moles, right? We have to go to moles. So we're going to go from grams to moles. And to do this, we're going to use that molar mass. And then we're going to go from moles to atoms. And to do this, we're going to use Avogadro's number. And so I like to map this out because for me, this gives me a plan and I can check it at each step. So I'm going to start with 1 gram of sulfur. And when I do this, right, with my 1 gram of sulfur, I'm going to say, look, I'm going to look at the periodic table and I know there's 32.059 grams of sulfur in 1 mole of sulfur. And so I can see here that my grams of sulfur cancel. I'm left with moles of sulfur. I have done this step successfully. We are now at moles. So I can use this map to get me from what I have to what I'm asked for. The next step here is I'm going to come in and I'm going to say, okay, I need Avogadro's number. I know Avogadro's number is in 1 mole of sulfur, there's 6.022 times 10 to the 23rd atoms of sulfur, right? And so when I look at that, right, I can come here and I can see that my moles of sulfur cancel here and I'm left with atoms of sulfur, which is what I'm looking for. So before I pick up my calculator, I have a built-in double check by checking my map, making sure my units cancel. So now in my calculator, I'm going to take 1 gram. I'm going to divide it by 32.059 grams because that's in the denominator. And then I'm going to multiply by 6.022 times 10 to the 23rd. Please go ahead and do this so you can practice putting it in your calculator. When I do this, I get 1.8784 times 10 to the 22nd atoms, right? And now I'm going to check my sig figs. So I'm going to come here for my sig figs and see I have 3 significant figures there. That means I need to have 3 significant figures here. So I'm going to look at that 8 for rounding. And that tells me I need to round to 1.88 times 10 to the 22nd atoms. Please go ahead and try these in your calculator. We want to make sure that you're very comfortable plugging these in. We'll do more examples of these in class. And as always, please come to my office if you have any questions.